This is the coding section of the profit model. These are the libraries we will need, and the install packages have been commented out. This data is about demand for homeless shelters in New York City. So how many people require a shelter on a given day? To make this more complete, the creators of this data set included holidays and the maximum temperature in Celsius for each of the days. There are several potential outcome measures, but we will focus on the total number of people living in shelters, which is tracked by Department of Homeless Services. When we open up this data frame, we see the first variable on the left is the date of the recorded entry, and the second variable on the left is our outcome variable. When we look to the right in the data frame, we see our holidays and temperature variables. Profit is super particular about the way it likes to see the data. The date variable needs to be formatted to exact specifications. So let's go ahead and do that. There are lots of extra columns which are breakdowns of our target variable, total individuals in shelters, and we will use a select statement to keep only the necessary columns. We change the variable names because the profit model is particular and requires specific naming conventions for the inputs. They have a structure and our data needs to fit that structure. We change our date variable in the first column to DS, and then we change our outcome variable to Y. Let's create a plot of our dependent variable over time. As we can see, the data ends after the start of COVID. Therefore, I will truncate the data at the end of 2019 and focus on the pre-COVID data. I will draw a line and exclude the data to the right. We exclude data for 2020 by using a select statement. We are truncating data to remove the COVID disruption to the pattern. If we run the exact same timeline plot after the removal of the COVID time period, we no longer see the precipitous drop associated with the onset of COVID. Now, the data stops at the beginning of 2020. Next, we will code our holidays. We will code 2, which are Easter and Thanksgiving. We will have Christmas be a regressor along with temperature. As mentioned in the previous video, holidays are handled differently than regressors. For Easter, we create an object which we will call Easter. The object will have 3 things: the name, the dates, and the lower and upper window. To create this object, we use the function tibble. Now let's do a similar coding for Thanksgiving. Note that we typically do some descriptive analysis to determine the upper and lower windows. For Easter, we have selected a lower window of -4, meaning 4 days before Easter Sunday, and the upper window of 2 for 2 days after Easter. For Thanksgiving, we have a lower window of -3 and an upper window of 1. Finally, we merge our holidays using the bind rows function to combine Easter and Thanksgiving. We can open this holidays data frame and see the holidays, along with dates and upper and lower windows. For our test and train split, we will use the data from before September 2019 for training, and for our test, we will use the 4-month period from September 2019 through the end of December 2019. We are ready to set up the profit model. This can be as simple as loading the holidays and leaving the defaults, but let's take a look at the settings. If we were to do parameter tuning, we would want to focus on some of these knobs and levers, such as number of change points or prior scales. But for this exercise, I will only change the additive default and seasonality mode to multiplicative. By changing to multiplicative, our component decomposition plots are presented in percentages instead of raw numbers, and this aids in interpretation. Next, we add our regressors of Christmas and temperature. Then we fit the model to the training data. Note that when we run fit, our daily seasonality is disabled because the model automatically recognizes that a single day is the smallest unit of time. Therefore, our weekly seasonality will give us our day of the week decomposition. When we run the regression coefficient function on our model, we get information in the display console, which is in the lower left of the screen. We see that the coefficient numbers for Christmas and temperature are both negative. So there is slightly less demand for shelter on Christmas. For temperature, as Celsius increases by a single degree, there is a slight decrease in demand for shelter. Before we do forecasting, there is a step we need to prepare, which is to create a future data frame. We need to get the future values of the regressors, and Profit has built the Make Future Data Frame function to help with this. For this, we need to include our model, M, and the number of periods, which is simply the number of rows in our test data frame. Then we append to this our future values for Christmas and temperature. Now we are ready to make our forecast. For this, we use the predict function along with our model, M, and our future data, and we will soon be ready to look at some visualizations. Here is some code which looks at the impact of Thanksgiving in our test period. It indicates very little impact with slight increases in housing demand before Thanksgiving, and then a slight decrease on Thanksgiving Day, and then a return to slight increase in demand the day after Thanksgiving. Now we will do 3 plots. The first is the general forecast, the second is dedicated to the structural components, and the third is a deep dive on the trend. For the general forecast, we need the model, M, and the forecast. When we run this, it will appear in the plots, and then we can zoom in. What we see is that the model fits the data very well. The black dots are the observed data, and the blue line is the prediction. From September 2019 through the end of the year is our forecast. As we can see, there is a dip in the 2019 trend in the summertime below the most recent prior years, and therefore we are projecting similarly depressed numbers for 2019 in the later part of the year. Next, we will look at the structural decomposition. For this, we use the function profit plot components. We have here 5 graphs. The first is the trend, which increases in the beginning and then trails off toward the end of the time series. The second is the holidays. Note we see a slight uptick around some of the days for Thanksgiving and a decrease for Easter. Even though the Easter impact seems large, it is less than 0.5%. On the third chart, we see day of the week variation, with a notable drops on Friday and Saturday. The fourth chart is the yearly, and this has a nice smooth shape which we like to see for seasonality. This is a very big impact compared to some of our other variables because it ranges from +2 to -2%. Finally, at the bottom, we have our extra regressors of temperature and Christmas. Temperature has the expected impact of being negatively associated with shelter demand. So when temperatures are low, demand increases. For the last plot, we add change points. This is just the prior plot with the plus sign and a function named add change points to plot. We can zoom in, and as you can see, there are many changes. So many changes might give us the best result, but from a realistic point of view, we might not want to say that our trend changes this much. One of the questions you might have is why there are no changes toward the end of the series. What happens is that Profit has this rule where a few months before the end of the time series, the trend does not change. The last thing we want to do is measure the accuracy. For this, we want to isolate our predictions in the test set and compare this to what actually happened in the testing data. In the console window, we see our accuracy statistics where we have a very low MAPE of 0.35%. MAPE stands for mean absolute percentage error and is a good way to judge model accuracy. Our output also include root mean square error, and it is good to look at this as to see if there is substantial difference with the mean absolute error. If the RMSE is a lot higher than the mean absolute error, then there are outliers or extreme values driving this difference. I appreciate your time. Thanks for watching.